So this is Flat Earth Dork, and I'm with Flat Earth Hippie, and it looks like Hippie has come up with a different curvature calculation than the one that most Flat Earthers have been using. So why don't you go ahead and try to explain this? He's going to explain it to me, because I haven't really heard this yet.
Okay, well, anyway, that curvature chart as I saw it, just never did really set well with me, and it just seemed too tight, and so I thought I'd plug in the calculations here and see what we came up with. This, of course, being a 24,000 mile circle, so I want to find the curvature of half of this 24,000 miles circle. So starting here, 12,000 miles around to here, that takes me halfway through it, and that should give me a curvature drop of 3,950 miles, which is the radius of a 24,000 mile circumference circle, which is our globe, whatever we're figuring this at. So let me go ahead and put my calculations in here. It's 8 inches per mile squared, so 12,000 times 12,000 equals, okay, and we're going to take this down to, 8 inches now, so we're going to go times 2 divided by 3. That'll put us back to feet. We get 96 million feet. We're going to divide that by 5,280, which will give us the number of miles that this curvature should be. So divided by 5,280 equals 18,181 miles of curvature on a 24,000 mile sphere or ball. Well, that's not right. As best as I can tell, maybe somebody can help me out with my math. So I played around with it a little bit. I didn't get it exact, but I've got it figured out that it's probably closer to somewhere less than 2 inches per mile squared, and I'll try that math for you and plug it into this formula here. So 12,000 times 12,000 times 2 inches divided by 12 takes it back to feet equals, and we divide that by 5,280, which will give us miles. And we come up with about 4,500 miles as the curvature. So,
in fact, look at let me see, what is that number on there? 45.
Yeah.
Five.
Anyway, so that number is also too big to fit the numbers that we have that we know are fairly accurate. So I'm supposing that the curvature drop is probably about 1.85 inches per mile squared, something like that. I haven't done the finished math on it, but I do know that the curve is represented as less than 25% of that chart that somebody gave us to use. And the chart, unless somebody can show me what I've done wrong trying to figure the curvature for half the globe, somebody please straighten me out on it. I see the curve is less than 2 inches per mile squared. It's still a curve, and we can't find it, and the Earth's still flat, but I think there's a problem with this calculations they've given us.
So, in essence, it didn't really make you happy to find this out.
Oh no, it's not what I wanted to find, but the other one wasn't setting well with me, so I thought I'd just investigate it a little bit, and this is what it came up with. And
Right, and I was asking some questions too, like, wonder if we did the math backward or inside out or inverted or, because things should be, things should work out always, right?
like cutting it into many pieces of pie, as you suggested, 1 mile pieces of pie, and put them all together.
Right.
Yeah.
Because we just weren't really visualizing this 8 inches per mile squared.
Well, I kind of was. That's why I finally
yeah,
had to. I mean, it
we
just
were trying
didn't,
to visualize it.
Yeah,
so,
right, yeah.
This is kind of disheartening to maybe think that, but maybe,
Well,
I don't know, maybe Hippie is losing his math touch, but
Yeah.
I kind of doubt it. But somebody really should.
Please check me, figure it out. Show me where I went wrong.
Check us on that. One of you mathematicians, Metabunk or
Yeah.
whoever.
Well, he's under the same delusion. He's using the same flawed.
Yeah, and he thinks he's on a ball.
Yeah, that too.
And he thinks he's a scientist and all that stuff.
Yeah,
and went to space and all kinds of crazy things. So, but yeah, I think he uses 8 inches per mile squared too. But that seems to be, most people seem to agree that that's what it is. And now
I don't agree.
And your contention is
less than 2 inches per mile squared is what the calculation would be to come up with the figures that we're given for our alleged circumstance of a 24,901 mile ball with a whatever radius is going to be less than 2 inches a curve per mile squared. The way I got it figured, please show me where I'm wrong.
Yeah, I mean, it's a little disappointing to us because, like, we have pictures and we've been circulating them around of Mount Shasta, and it's 100 miles away, and we've been just repeating that it's
6,700 feet should be obscured.
Right, which isn't.
Yeah.
But in reality, it's about 1,700
Closer to 1,700 feet.
Yeah, or something like that. That should be obscured. And we still think that it's flat. I mean, we know that water remains level and the earth is mainly water. And so what we're saying is there's less curvature there will be less obstruction that you would see if the Earth were a ball 24,000 miles in circumference.
Mm-hmm. It doesn't change the fact that the horizon always rises to meet your eye, and the situation even at a curve of a quarter inch per mile squared, the horizon is still going to fall away from you on a ball. It doesn't change the fact that we don't live on a ball. It's just exposing that we've maybe been suckered by somebody with a formula that doesn't fit our model.
Yeah, and I have plausible deniability because I'm not a mathematician and I don't understand it really, But I do ask questions, and I kind of prompted this question a couple of times,
mm-hmm.
and does the math work out if you approach it a different way? And so, yeah, if somebody thinks we're just complete, crazy dork hippies, let us know.
Yep, for sure.
And let us know if that, if that floats your boat. And thanks for listening.